Hey guys, I'm going to make you understand today the third part of our refraction through the plane surface, that is real and apparent depth. Just to understand the real and apparent depth, you have to remember certain things, that when an object is placed in a denser medium and viewed from the rarer medium, then the object appears lesser than that of the actual real depth. Lesser than that of the depth, then its actual depth. This is known as the apparent depth. So this is one of the example based on which there are so many consequences are there, for which when a child or when a person puts his legs, that is four leg, within the swimming pool and sitting just nearby it, and when they are observing, then the legs appear to be smaller than that its actual length of the leg. This is one of the example. There are so many examples are there. Stars are twinkling in the skies. Actually it is not twinkling, it appears to be twinkling because of the refraction. So these all are, there are so many consequences based on it. And let's I'm going to show you how the refractive index is related to the real depth and apparent depth. Let us learn. Here is, you can see this BOC. OC is one of the incident ray. When OC is incident ray from denser medium to the rarer medium is our CD, then in this case what happens? You can see angle of incidence is this one. So when OC is one of the incident ray, that is O is the object in the denser medium, I took it as a water medium, and the light ray is traveling from O to C and C to D is refracted away from the normal when the object O is viewed from this denser medium obliquely. Then angle of incidence is I and angle of refraction is R, and if it is this OA prime is parallel to n prime and this is the transversal, then this angle is equal to this angle, that is angle of incidence. When I produce the CD, this object when it looks from outside from rarer medium obliquely, then it appears to come from the B point, that is angle of refraction NCD is equal to angle ABC. NCD equal to angle ABC, that is a R I took. AOC, this is AOC, this angle of incidence equal to angle OC n prime, that is I. Now in triangle AOC, sin I is equal to how much? Sin I is equal to P by H, P is AC by OC. Similarly in triangle AOB you can see sin R equal to AC by BC, SI Now if you find out the refractive index of the air medium with respect to water medium is sin I by sin R, AC by OC by AC by BC. SC and AC cancels, BC goes to off, BC by OC. BC by OC and BC, if the C point is not very far from A, will consider, then BC is nothing but is equal to BA, BC is equal to BA, and OC is equal to how much? OA will appear. That is mu A with respect to water is equal to BC by OC, which is approximately equal to AB by OA when C is not very far from, or we can say that it is very close to A point. Then refractive index of the denser medium, water medium, is equal to 1 by mu A W, OA by AB. This is real depth by apparent depth, and apparent depth equal to real depth by mu W A, we can say. Now the difference OB is equal to OA minus AB, that is real depth minus apparent depth, and in the place of apparent depth substitute real depth by mu W A, you will get shift is equal to mu W A, 1 minus this is. Now what are the factors depending on the shift? Is a refractive index, that is directly proportional to the refractive index. It is also directly proportional to the thickness of the denser medium, and it is inversely proportional to the wavelength of the light ray. Apparent bending, for this region when you put a pencil also or you put a stick, then you will find that obliquely then the stick looks bent from its point of separation of the two media. So there are so many consequences are also.